All right, here we go. A little bit different today. You guys can all graph lines, correct? All right, here's the difference today. I'm only going to ask you to graph part of a line, not the whole thing today. All right? What we call piecewise, that's literally what it is. You're going to graph a piece of a function. Not the whole thing, just a certain part of it. All right, we're going to do two of them and kind of connect them together. So let's take a look at this first one right here. I'm going to ask you to graph 2x plus 4 and 6 minus x. All right, let me start with the 2x plus 4. Now, I'll do it on mine. You just look up here. 2x plus 4. We all know that's going to be a line. I do not want that whole thing graphed, though, today. I want a piece of it graphed. What piece specifically? Look at my restriction now. It says only to graph what x values? -4 to +1. So here's what you got. Take a look at my graph, guys. Here's literally what you're going to see right now. -4, 1, 2, 3, 4, to 1. I only want to see that part of the graph today, from -4 to 1. All right? So what I'm going to have you do first is we're going to set up a table for each of these. Wherever you can find room to set up the table. All right, the first table is going to be y equals 2x plus 4, the equation they gave me. Just like we did for our parabola in the previous unit, I'm going to make an xy table that I'll get directly from my graphing calculator. What x values do I want in my table right now? What are the restrictions? -4 to 1. So ready, -4 has got to be on there. What else? Let's keep going. -3, -2, -1, 0, and 1. Go ahead, everybody, and fill in your table now. And you can go ahead and once you're ready, graph your points. Share the straight edges around for me. And I shouldn't see any arrows. Nothing. I'm just connecting the points for the x values they told me to. That's it. A piece of that graph 2x plus 4. Now go ahead. Let's go. Everyone all right? Can I move ahead? Now I can go and do y equals 6 minus x. But now you'll see a little slight change as far as the requirements. Anybody see a slight change in the requirements from the first one I did? Caitlin? Okay, 1 to 5, and there's nowhere equal to there. I'll talk about that when we graph it, though. Okay, so you are still going to set up your table from 1 to 5. I would just appreciate it. Don't graph it yet. Graph it with me. All right, so set up your XY table. Your X's now are from 1 to 5. Go ahead. Find those new Y values. I would just appreciate it, though, if you just stopped after you found them. Do not try to graph it. Some of you may be able to predict what's going to happen. Everyone ready to graph with me? Ready to go. Okay. Notice it said 1 to 5, but do you see how there's no or equal to there? Which means there's no value at 1. But what we're going to do is, what was the y value at 1? 5. And because there's no or equal to there, I do not want to make a solid point. I want to make an open circle there. So at 1, 1, 2, 3, 4, 5, I'm not going to make a solid point. I'm going to make an open circle. All right, I didn't need the value at 1, so I will put an open circle there, and the rest now can be solid. Okay, including the one at 5 because there's an or equal to there. It did not include 1, so that's why you guys are seeing an open circle there. So go ahead and graph the rest of your points. And there is your first piecewise function. Okay, so if it doesn't have the or equal to, I put an open circle there. Not too bad. We just graph what they ask. Okay, now we got to unfortunately answer some questions now. What's my range? Range. What values, x or y's for the range? Y values. All right, I need somebody to tell me right now what's the highest and the lowest y value that are graphed. All right, the highest and the lowest y values that are graphed right now. That's what I'm going to ask somebody. Highest and lowest y values. 4, when you're ready. Highest and lowest y values. Yep, and the lowest it goes to, because it doesn't go to infinity, it goes to. Okay, so how do I write that from yesterday? It goes from -4 to 6. -4 less than or equal to y less than or equal to 6. Or, as we discussed yesterday, bracket -4 comma 6 bracket. Okay, from -4 to 6. Yes. It always goes least to greatest. Correct. Least to greatest. Good question. Least to greatest. So yes, 6 to -4 would be incorrect notation. All right, how do you guys feel? All right, I know I went pretty slow on that, painstakingly slow, but we can pick it up now. All right, here you go. New piecewise, give you 2. Here are the restrictions. Evaluate it now. What is f of 5? Whoa! I need your help, guys. I got 2 equations up there. Which one do I plug 5 into? And how can you tell? Because there's only one equation you're going to plug 5 into. You can't plug them into both. Only one will be allowed to plug 5 into. Look at the restrictions. Look at the restrictions. Which one can I only use 5 in? Take a look. Which one can I only use 5 in? I have x is less than or equal to 1 for this one. X is greater than 1 for this one. Which one am I allowed to plug 5 into only? 5? Ha! Look at that. Why? Correct. X less than or equal to 1, 5's not in there. But 5 is in greater than 1. So I'm going to take 5 and plug it into 2x minus 1. So 2 times 5 minus 1. So f of 5 would be 9. Now what about f of -2? Where am I going to plug -2 in? Where am I allowed to plug -2 in? 15? X squared. Yep, because that -2 is less than 1. Ready? 8. -2 all squared, so that'll be equal to +4. Anytime you square a negative number, it's positive. Carefully evaluate f of 1. There's only one up there that it can go in. Can't, Matt, what are you going to tell me? Why? This is the only one that's or equal to 1. Yep. So 1 squared, f of 1, is going to be 1 squared or 1. All right, you ready to? Yes, Marco.
So for X or for F, it's -2.
Yep.
Wouldn't you plug it into the bottom one?
Why? Look at the restriction on the bottom one. You can only use this for x is greater than 1. Is -2 greater than 1?
No, I thought the answer has to be greater than.
No, this is where you're graphing. Like, you can only use this equation with x values bigger than 1. You can only use this equation for x values less than or equal to 1. See where we're going there? You sure? Everybody else all right? All right, let's graph them now. Part D is, where's part C? There is no part C, huh? All right, part D, we're graphing them. Just like we did the last one, so go ahead. X squared. I'm going to ask somebody, what should your x column look like now if I'm going to graph x squared with that restriction? What should your x column look like right now? Here you go, 23. What should my x column look like? Okay, well, hold on. What should be my first value for underneath here if my restriction is x is less than or equal to 1? Okay, ready? 1. Keep going, Callie. 1. Okay, just get a couple going there, guys. Get a couple going. Let's go. Get a couple going. Bless you. Bless you. Looks like you can graph so much. And if you guys want to see if you can do the next table. All right, for x squared, you guys know this is a smooth curve because it's a parabola. And we don't stop, right? We keep going because it says anything less than or equal to 1. All right, I'm curious, how are you going to start your table for 2x minus 1 based on the restriction? The restriction is x is greater than or equal to 1. Here you go, 8. What do you want to put in this x column? Okay, still start with 1. Yep, even though I know it doesn't have an or equal to, I'm still going to start with 1. Go ahead, Fiona. 2, 3, 4, 5, however many you want to graph, so you get the idea. All right, ready? When I graph these, take a look. When I graph these, does everyone see? Did it include 1 for this graph? Did it include 1? No, so many of you are saying, well, on the last problem, you put an open circle there, right? What's my y coordinate for 1 on this graph? 1, 1. And if I go there, what's already there? So keep it there. I don't want this. No, we don't put that. If it's already shaded, keep it shaded. All right, there's no need to put an open circle around it. All right, if it's already shaded, keep it shaded. So 1, 1, here we go. 2, 3, 2, 1, 2, 3, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. Now I gotta harp on this because I'm going to be a stickler with this. Is this a parabola? No, this is a line. So make it look like a line with your darn straight edges. All right, it shouldn't be just continuing on. Shoot. Hey, it shouldn't be this right here. Whoop, that's a no. Make it look like a line as much as possible with your straight edge, please. Yep. Nope, because this is all one. This is all one function. So this is one graph we're doing right here, Marco. Okay, not 2 separate ones. All right, this is one graph. Again, one graph called f of x. All right, and this is how I make it. Questions, comments? Because now I'm going to go in reverse. What if I give you the piecewise? Can you give me the equation now? That's where we're going. Any issues graphing? We feel pretty comfortable graphing now, making our own tables. Open versus closed. We're all good? Okay, here we go now. What if I have to come up with my own equations now? I'm going to give you the piecewise now. All right, I'm going to give you the piecewise. There it is. Broken up, everyone see? Broken up into 3 parts. A, B, B, C, and C, D. All right, at the end, I'm going to show you a process here. So at the end, we can write our own piecewise equation. Let's start with slopes. Please, I'm praying. Please tell me you've done something with slopes this year. Rise over run? Okay, all right, we can start there then. Good. All right, rise over run. We'll start there. All right, slope. I'm asking you to find the slope of each of the 3 pieces. Let's start with AB. Everyone start at A and go to B and tell me what the rise over the run is right now. Okay, that's going to be finding the slope, the rise over the run. Up and over how many? Up and over how many? Whew, 28. Up and over how many? That's right, we don't have one, only 30 kids, right? 17? 6 over 4. I'd like you to reduce that if you could. Anybody? 6 over 4 goes down to 2/3? 3 halves, yep. Okay, so 3 halves. BC, what type of line is BC? Don't tell me a straight line. Get out of here. Horizontal line. Anybody remember from back in your day, slope of a horizontal line? Going to drop some knowledge, Olivia? 0. Yes, any horizontal line has a slope of 0. And then go ahead, guys, quickly do the slope of CD. Rise over run for CD. I may catch a couple of you here. CD, rise over run. Let's do this. Here you go, 10, rise over run. Whoa, stole my fire. I thought somebody was just going to say 1/2. Why is it negative 1/2? It's going down. This one was going up, left to right, so that was positive. This one's going down, left to right, so it's negative. Nice job. Everyone all right? Because now we actually have to find the equations of these lines. All right, we're going to find the equations. Let me start with BC because that's the easiest. What y coordinate does it go through? What y coordinate does it go through? 3. Any horizontal line, it's just going to be y equals where it goes through. Where does it go through? 3. Perfect. Have you guys done equations of lines? Let me ask you that before I get into this. How to write the equation of a line. All right, they all come in this form. Everyone familiar? Y equals mx plus b. All right, let's jot that down for AB. I wish I could spend more time on this, but I can't. But homework tonight, please reference your notes that we're doing right now. All right, anybody remember what the M was? Slope, all right? X and Y are a point on the line. B was called your y-intercept. That's what I need to find right now to write the equation of this line. All right, so let's go to AB. Can somebody give me a point on AB? Any point on AB. Any point. 4, 1, 2, 3. Is that 4, 0? 4, 0? Negative 4, 0. Everyone agree? Negative 4, 0 is on this line. All right, here you go. What's the y coordinate? Actually, you know what? I'm not good. I need somebody. 11? Who's got 11? Okay, here we go. Right. What's the y coordinate, Jenna? 0. So ready? Everyone plug in 0. What was the slope we found earlier in this problem of AB? I'm not asking you. Jenna, what do you have? 3 over 2. What's the x coordinate we just picked? Negative 4. Everyone right now, please solve for b now. Please solve for b. So get b by itself so I can find that y-intercept. And I know I didn't give you much room. I apologize. So multiply those two, move it over, get b all by itself. When you're ready, number 9, when you're ready, let me know the b value. 6, perfect, nice job. So the b is 6. So what's the equation of AB? Everyone ready? Y equals, what was your slope? What was your slope? 3 over 2x plus, what was my y-intercept we just found? 6. That's the equation of AB, everybody. Yes, Matt? So you're saying, okay, I know the slope's 3 over 2, so I go up 3 over 2? Yeah. All right, but the problem you may run into is if it doesn't actually cross at a point, maybe it crosses like at a halfway point, that's going to be an issue. Okay, was that what you're going to ask, Sam? Okay. All right, let's do it for CD now. Find the y-intercept for CD. Somebody pick a point off CD for me. Any point on CD. 13, any point on CD, pick for me. 4, 2, okay. I like how you guys are picking points actually in the middle. You can pick C or D as well. You know that. All right, just realize that too. You could pick C or D. All right, but that's fine. 4, 2. Here we go. 4, ready to go? What's the y coordinate we picked off? 2. What was the slope of CD? Times the x coordinate we just picked off. 4. Everyone go right ahead now and solve for b. Exactly what you're going to do on one of tonight's problems. When you're ready, what's the b value? When you're ready, 9. When you're ready, what's the b value? 4. Great job. 4 is the y-intercept, so that means what's the equation of my line now? 12. What's the equation of CD? Y equals? What was the slope? Negative 1/2 x plus 4. All right, we got all 3 lines now. Now we can finally write the piecewise. Ready? F of x equals, and we get to make these cool little braces here. Good luck drawing those. All right, I won't judge. How many lines did we have? How many lines did we have in our piecewise? 3. Ready? 3 halves x plus 6. Ooh, how do I write that? Y equals 3. I'm literally just going to put a, because what's f of x another name for? Y. So what do you think I'm just going to put here? Yeah, 3. And then what was the third equation? Negative 1/2 x plus 4. What am I still missing, though, from the piecewise? What am I missing here? Look back at the piecewise we've just graphed. The restrictions, right? The domains. All right, I'm missing the domains. Yes, good. Okay, ready? Negative 1/2 times 4 is negative 2, right? How would I move that negative 2 over? How would I add negative 2? Here, I got this right here. 2 equals negative 2 plus b. How am I going to move that 2 over? 2 and 2? You okay? Okay, good question. All right, help me find the restrictions. Here is AB. What x values contain AB? Count them right now. What x values? From what to what? What x values contain AB? From what x to what x contains AB? Because I'm going to write this as an inequality right now. I'm getting rattled. There we go. Come on. Act like you've been there. Here you go, 27. What are my x values here? Negative 2 to negative 6. Everyone agrees? Write it as an inequality. So I'm going from negative 2 less than or equal to x less than, actually, sorry, I'm writing in the wrong direction, aren't I? Matt just asked this before. You do the smaller number first. Negative 6 less than or equal to x less than or equal to, what was the end point there, Hunter? Negative 2. Nice. There we go. Do it for 3 now. Go ahead, do it for 3. From what x value to what x value now? Got it for me there, 7. 7 x values. Negative 2 to 2. And all these are closed circles, so I'm putting or equal to. And finally, how about CD? From what to what? Let's finish this beast up. What x values? 14. What x values does CD go from? Negative 6 to 2. CD. What x values? 2 to 6, right? 2 to 6. Congratulations, you've made your first piecewise. Questions? Because I'm go. No. When you write a piecewise definition, good question. When you write a piecewise, it's got to be an inequality.
Do you close that? Do you make another one on the
I don't know. I'll be honest with you, Emma. I've never seen it. I've always seen it just open like that, but I don't think it's wrong if you close it. Okay, but I've never seen it like that. I don't know. Other questions? All right, I'm done. I want to see you do the next one on your own. Find the values of 4 and negative 3. I want you to see you graph it and then do the range. If you want to work with people around you, feel free. All right, this is how we're ending it. Don't pack up early. I'm going to go around to each group and see how you're doing. Okay, talk about it if you need to. You can only plug 4 in a certain one. You can only plug 0 into a certain one.